Welcome to an animation that compares polar and rectangular coordinates. Most of us are very familiar with rectangular coordinates, as we see here on the screen, where each point can be identified by an ordered pair consisting of an x-coordinate and a y-coordinate, where the x-coordinate tells us how far left or right to go, and the y-coordinate tells us how far up or down to go. So as we animate this point, on the right, you can see the x and the y coordinates changing. Now what we want to do here is compare how we identify the location of points in rectangular coordinates compared to polar coordinates. So what we'll do first is turn off the rectangular grid and turn on the polar coordinate system. Next, let's also show the polar coordinates and the rectangular coordinates at the same time. Now recall, when we're plotting points using polar coordinates, they're in the form of r comma theta, where r is the directed distance from the pole, this blue distance here, and theta, the angle formed by this ray and the polar axis. Now remember that polar coordinates are not unique, so what this is showing us here is a positive value for r, and then the positive angle theta formed between this ray and the polar axis. So as we animate this point now, you can see that the radius of the circle, or the directed distance from the pole, is changing, as well as the angle between the ray pointing to the point and the polar axis. Now just keep in mind that polar coordinates are not unique, so there's an infinite number of ways to identify this point using polar coordinates, but what's listed here is probably the most obvious one, with a positive value of r and a positive angle for theta. We should also begin to see the relationship between rectangular coordinates and polar coordinates. Remember, there are four formulas that relate polar coordinates to rectangular coordinates. One of them is x squared plus y squared is equal to r squared, based upon the Pythagorean theorem. It's also stated that tangent of theta would be opposite over adjacent, or y over x. We also have that cosine theta would be equal to adjacent over hypotenuse, or x over r. If we solve that equation for x, we'd have x equals r cosine theta, and also sine theta would be y over r, or y is equal to r sine theta. So it's kind of nice to see both coordinates at the same time, so you can see how they relate to one another, and also you can see how rectangular coordinates would be unique while polar coordinates would not be. So hopefully this animation supplements the videos I've already created to explain rectangular and polar coordinates, as well as graphing polar equations.